So this is curve sketching, and this function is not on your notes, but it works out nicely, so I'm going to use this one. Um, First, we see that the function is x to the fourth power minus 4x cubed, and let's find the domain of the function. Domain, that's going to be x is all real numbers, right? In the range, because it's to the fourth power, I know it's going to make maybe overall this U shape, maybe a double U shape. So I don't know exactly what the lowest point is going to be, and we'll figure that out later. Let's find the x and y intercepts. X-intercept and the y-intercept. Okay, when x is 0, y is also 0. So that's going to be both my x and y intercepts, and it goes to the origin. And let's factor out x to the fourth power, x to the third. That's x minus 4. And that means y is 0 when x is 4. So 4 comma 0 is another x-intercept. So I'm going to plot those 2 points here. Okay, those are the 2 points that my graph's going to go through. Let's look at f prime. That's 4x cubed minus 12x squared. Factor out 4x squared. You get x minus 3. So f prime of x is 0 when x is 0 and 3. And these are your critical numbers, right? That's when f prime is 0, your slope of the tangent line is 0. They're candidates for your local max or min. So I'm going to make a number line and find out the sign of f prime. Okay. So any negative number, so 4x squared is always going to be positive, so I just have to look at this x minus 3. So negative number minus 3, it's going to be negative, so the function is decreasing. Between 0 and 3, let's say 2. So 2 minus 3 is negative. Again, it's going to be decreasing. And anything bigger than 3, minus 3 is going to be positive, so the function is increasing after 3. Okay. So if the question asks to state the interval where f is increasing or decreasing, then you have to say it's increasing from 3 to infinity, or when x is greater than 3, and decreasing from negative infinity to 0 and 0 to 3. All right. I noticed that we can have a local min at x equals 3. So local min at x equals 3. And what is that value? So f of 3, if I plug it into this equation, that's going to be 27. 3 minus 4 is negative 1, so negative 27. Okay, so 3, 20, 25, somewhere right there maybe. Let's call this 3 comma 27. Okay, min. All right, and let's find the second derivative. And I'll just change colors here so I can mark on this side. F double prime of x is equal to let's see, 12x squared minus 24x. I'm going to factor out 12x. It's x minus 2. So f double prime of x is 0 when x is 0 or 2. These are your candidates for POI. Right? You're not guaranteed that you're going to get a point of inflection, but this is a good place to look. All right, x equals 0 and 2. So let's make another number line for f double prime. Sign of f double prime. Okay, negative number. So here's a negative number times a negative number. It's going to be positive. We have concave up from 0 to 2. That's going to be positive. This is going to be negative. You have a negative. F double prime, concave down. And anything bigger than 2, that's going to be positive. This is also going to be positive. You have a positive sign right there, concave up. So it turns out x equals 0 and x equals 2 are both points of inflections. Okay, so I know that f of 0 is 0. What is f of 2? So f of 2 look at it here. That's going to be 8 times 2 minus 4 is negative 2, so it's going to be negative 16. So 2 and negative 16, maybe right there. Okay, that's a point of inflection. And this is also a point of inflection. Here my slope is 0. Here my slope is 0. Okay, so I have these two. Let me see. Okay. This number line and this number line here. You can look at it separately, but I'm going to combine them. Okay, just down here. Alright, so 0, and I need a 2 there and a 3. So here, anything less than 0, your function is decreasing, and it's concave up. Right? Between 0 and 2, function is decreasing. In fact, function is decreasing here as well, increasing over here. 0 to 2 is concave down. And anything bigger than 2 is concave up, so we can just write concave up here. Okay, knowing this, along with all the points that we found, we could graph the function. Alright, so it's decreasing concave up from anything from here, like maybe like that. Okay, it won't be vertical, but there. And then from 0 to 2 is decreasing but concave down. Okay. Okay, and then from 2 to 3, it's decreasing concave up again. Okay, from 3 and on, it's concave up increasing, but it has to go through that point. Like that. Alright, so that's our curve.